Hello, this is Math Jazz from Almost Cool. I have a trigonometry quiz for you. I will show you the questions and read them to you, and then I will solve the questions. So if you need time to do the questions, you should pause the video so that you can work out your solutions without them being spoiled to you. Here's the quiz. Problem 1a. Convert 210 degrees into radians. B. Convert 3/4 pi radians into degrees. Problem 2. A. If sine of x equals 4/5 and cosecant of y equals 13/5, what does cosecant of x plus y equal? Assume that x and y are in the first quadrant. B. Compute the exact value of cosine of pi 12ths. Problem 3. Prove that tangent of x plus tangent of y is equal to sine of x plus y divided by cosine of x times cosine of y. And here are the solutions. Problem 1. Since 360 degrees and 2 pi are both ways of writing one full rotation around a circle, they're equal to each other. And so multiplying by one divided by the other is equivalent to multiplying by 1. It does not change the expression, it merely converts the units in which the expression is being expressed. So we can multiply 210 degrees by pi over 180 degrees without changing the value of the expression. We do that here. 210 degrees times pi over 180 degrees. Well, the degrees will cancel out, and then we simplify the fraction and we get 7 pi over 6. And this is the answer. Part B is done precisely the same way, with the exception of, since we are converting from radians into degrees, instead of having pi on the top of the fraction and 180 degrees in the denominator, we will flip the fraction. We'll have 180 degrees as our numerator and pi as our denominator. Multiplying by this fraction does not change the value of the expression. And here we go. 3 pi over 4 times 180 degrees over pi. We multiply those together. Then we cancel out the 4 and the pi, and we're left with 135 degrees. Problem 2. So, we do not know what cosecant of x plus y is, but we do know that cosecant is 1 over sine. And we have an angle sum identity for sine. So if we convert cosecant of x plus y into 1 over sine of x plus y, and then use the angle sum identity, we get this equality here, which is 1 over sine of x times cosine of y plus sine of y times cosine of x. So those were two steps done at the same time, but since we have both our reciprocal identities and our angle sum identities memorized, it should not be too hard to do. We were given in the statement of the problem the value of sine of x, so we can plug that in. And we're given the value of cosecant of y, but cosecant of y is 1 over sine of y. So if we flip 13/5 upside down, we get sine of y. So we can substitute both of those values into our fraction. We still need to figure out what cosine of y and cosine of x are, but we can use the Pythagorean identity for that. So we know that sine squared x plus cosine squared x equals 1. We plug in the value we know for sine of x, and we plug in the value we know for sine of y into the Pythagorean identity, and we solve for cosine of x and cosine of y, getting these values. That is, cosine of x equals 3/5 and cosine of y equals 12/13. We plug both of these into the fraction that we already have, getting this fraction. And at this point, we have solved all of the trigonometry part of the question, so the problem is solved for us. The rest is merely arithmetic, and that's not the point of the quiz. The point of the quiz is the trigonometry, and we're done with the trigonometry here, so the problem is solved. For part B, the first thing we're going to do is recognize that pi over 12 is equal to pi over 3 minus pi over 4. The reason we do this is we do not have pi over 12 memorized in our reference angles, but we do have pi over 3 and pi over 4. So this is a way of taking our reference angles, which are really a very small number of angles that we have memorized, and we can generalize or we can extend the usefulness of our unit circle and our reference angles by being able to use a combination of identities and addition and subtraction with our angles. So we rewrite the problem as so. Cosine of pi over 12 is equal to cosine of pi over 3 minus pi over 4. And now we use our angle sum identity, remembering that if we are subtracting one angle from another inside of cosine, on the left side of the identity, then on the right side of the identity, we will be adding our cosine product to our sine product, like this. So we have cosine of pi over 3 times cosine of pi over 4 plus sine of pi over 3 times sine of pi over 4. All of these are reference angles, and so we have all of these values memorized, and we can plug all of them in like this. Again, at this point, it's just arithmetic to solve. The trigonometry is done, and we can leave the problem like this. Problem 3. Prove that tangent of x plus tangent of y equals sine of x plus y over cosine of x times cosine of y. With this problem, we have, well, the first thing that we want to do is to convert tangents into sines and cosines. At this point, when we do this, it makes this a fairly straightforward calculation. So tangent of x plus tangent of y equals sine of x over cosine of x plus sine of y over cosine of y. And if we look at these fractions, we notice that if we were to add these fractions to get one fraction with one denominator, we would end up with cosine of x, cosine of y as our denominator, which is the denominator that the right-hand side of the expression of the equation had. So we will do that, and we get this expression. When we look at the numerator and we say, that looks like the angle sum identity for sine, and indeed it is, and so we rewrite using the angle sum identity, and now we have that the expression tangent x plus tangent y is equal to the right-hand side of this equation, sine of x plus y over cosine of x times cosine of y. And this is the solution, this is the proof to the problem, and we are done with the quiz. Thank you for watching this video. Feel free to email me. This is my email address. I would like suggestions on further topics in calculus, or I would also like if you could point out any mistakes or errors so I can correct them. Yeah, thank you and have a great day.